Hello students, welcome to AskPrep. My name is Gaganabi. In today's class, we will discuss about the third chapter, that is classification of elements and periodic properties. So let's move on to the topic. So we have studied in the previous chapter about the structure of atom and in the first chapter about some basic concepts of chemistry. In that we have studied about the elements, their properties, physical, chemical properties, their solubility, we have studied. Now we'll study the classification of elements. How are they classified and how are they grouped, and what is the name for grouping them, and how are they constructed? We'll study all those things. So this classification of elements in a periodic form is one of the biggest achievements in the history of chemistry. So why we need to classify the elements in terms of periods or groups? So it is a systematic way of arranging so that we can easily identify the elements, we can classify them, and we can also make sure that these elements are arranged properly in respective to their properties. It is also difficult to study individually the chemistry of more than 100 natural or synthetic elements and millions of their compounds. So you cannot study more than one element individually, it is very tough. So this periodic table, it helps in providing the systematic and organized chemical behavior of the elements into simple and logical patterns. So in periodic table, the elements are arranged in rows and columns. So from starting of the position, it is possible we can predict the chemistry. In this unit, we will study the historical development of modern periodic table, its function, and some of the periodic trends, its physical, chemical properties of the elements. So what is the history of the development of the periodic table? So how do we know how the first periodic table, when it was developed and all? So the first concept was given based upon this periodic table was Dobereiner. See, John Dobereiner was a German scientist and he was classified resembled the sodium property. In that way, he gave the octaves relationship. And this drawback of the Newlands Law of Octave is it couldn't apply for the elements having atomic weight greater than that of calcium. So calcium has atomic weight of 40. So above 40 atomic weight any elements it couldn't apply. And after the discovery of the noble gases, the property of the eighth element was no longer similar to the first one element. So the next one is Lothar-Meyer's atomic volume curve. So this is the transitions taking place between the elements. He was a scientist who plotted a graph between atomic weight and atomic volume, and he also found out that the elements with the similar properties occupied similar positions on the graph. So if the element has same property, it occupies the same position of the previous element. Strong electropositive elements of the 1A group except for lithium, that is sodium, potassium, rubidium, cesium, it occupies the top position on the graph. Lithium, sodium, potassium, rubidium, cesium, these occupy the highest position. Whereas the say 2A groups like the beryllium, magnesium, calcium, strontium, they occupy the ascending part of the graph. And inert gases occupy the descending part. So the below one is the descending part. Here the noble gases are present, even the halogens also. So the next concept who came about the periodic table was the Mendeleev. This is the important point where Mendeleev was the first person who gave a very good idea of a periodic table. So in 1869, Mendeleev, he is a Russian scientist. He used a broader range of physical and chemical properties to classify the elements. So what did he state? The physical and the chemical properties of the elements are the periodic functions of their atomic weight. So he gave, based upon the atomic weight, he grouped the physical and chemical properties of the elements. If the elements are arranged in order of their increasing atomic weight after regular interval, elements with the similar properties are repeated. So within regular intervals, elements possessing similar properties are repeated. So in the mid 19th century, the initial discovery which was made by Dmitry Mendeleev is an important value in the development of the chemistry. Mendeleev discovered 63 elements in the periodic table and he classified them as 7 rows, horizontal rows known as periods, and 8 vertical columns known as groups, which is numbered from 1 to 8. When all the chemical elements are arranged and there is a recurring pattern, this is known as the periodic law, in which all the elements in the column or group have similar properties. So if in the column, if it have the similar properties, that pertains to periodic law. So this is the Mendeleev periodic table. You can also notice here he left some blank spaces for the undiscovered element. So that any discovery could lead to the filling up of the space of these elements. So Mendeleev's periodic table was based on the atomic weight or the increasing atomic mass. While the modern periodic law, which we are studying now, is based on atomic numbers. So although Mendeleev's periodic table was based on atomic weight, he could predict the properties and the discovery of specific elements. Only half of the elements were known till that time and most of the elements were yet to discover and were not accurate. And he suggested certain elements discovery and he also assigned a gaps for the undiscovered elements and predicted its future discovery. So when the properties of the elements did not correlate to what it is expected from the group, they were named by prefixing eka to the preceding element. So you cannot either place in that group also or it is not correlating also. So he gave the names for few elements like eka boron, which is now silicon, eka silicon, which is now germanium, eka aluminium, which is now gallium, eka manganese, which is now technetium. So then what are the merits of Mendeleev's periodic table? So Mendeleev gave the systematic study of the elements and the atomic weights were able to determine with the help of the periodic table. So what is atomic weight? How to calculate the atomic weight then? Valency multiplied by its equivalent weight or group number multiplied by its equivalent weight. The atomic weights of the elements are also corrected. Atomic weight of beryllium was calculated to be 3, that is atomic the valency multiplied by the equivalent weight 4.5, which is 13.5 by considering its valency 3, but Mendeleev calculated it as 2 into 4.5, that is group number you get 9. So in Mendeleev's periodic table, two different consecutive members differ by 2 or 3 units in the atomic weight. But the gap was more. The discovery for the new elements, there was more gap left. So then what are the demerits of Mendeleev's periodic table? The position of the hydrogen atom is uncertain. It has been placed in first A group or 7A groups because it resembles both the characters of first group and the 7th group. And isotopes are not placed separately in the group, they are mixed with the elements. Lanthanides and actinides are not grouped properly. So even though there is no resemblance except valency of subgroups A and B, they have been put in the same gaps for the undiscovered elements and predicted its future discovery. So when the properties of the elements did not correlate to what it is expected from the group, they were named by prefixing eka to the preceding element. So you cannot either place in that group also, or it is not correlating also. So he gave the names for few elements like eka boron, which is now silicon, eka silicon, which is now germanium, eka aluminium, which is now gallium, eka manganese, which is now technetium. So then what are the merits of Mendeleev's periodic table? So Mendeleev gave the systematic study of the elements, and the atomic weights were able to determine with the help of the periodic table. So what is the atomic weight? How to calculate the atomic weight then? Valency multiplied by its equivalent weight, or group number multiplied by its equivalent weight. The atomic weights of the elements are also corrected. Atomic weight of beryllium was calculated to be 3, that is atomic of the valency, multiplied by the equivalent weight 4.5, which is 13.5 by considering its valency 3, but Mendeleev calculated it as 2 into 4.5, that is group number, you get 9. So in Mendeleev's periodic table, two different consecutive members differ by 2 or 3 units in the atomic weight. But the gap was more. The discovery for the new elements, there was more gap left. So then what are the demerits of Mendeleev's periodic table? The position of the hydrogen atom is uncertain. It has been placed in first A group or 7A groups because it resembles both the characters of first group and the 7th group. And isotopes are not placed separately in the group, they are mixed with the elements. Lanthanides and actinides are not grouped properly. So even though there is no resemblance except valency of subgroups A and B, they have been put in the same group. And the increasing order of the atomic weight is not followed in the arrangement of elements. For example, cobalt, the atomic weight is 58.9, is placed before nickel, which is having the atomic weight of 58.7, and argon, which is having 39.9, is placed before potassium, that is 39. So long form of periodic table or Moseley's periodic table is the next periodic table which we are now following. This is the periodic columns and 7 horizontal row. Moseley in 1909, he studied the frequency of X-rays which is produced by the bombardment of a strong beam of electrons on a metal target. So he bombarded a beam of electrons on some metal. So what did he found? That X-rays is directly proportional to the number of nuclear charge of the metal. So root of V is equals to A into Z minus B, where A and B are constant. The nuclear charge of metal is equal to the atomic number. Hence, Moseley related the properties of the elements with their atomic number and they gave the new periodic law. So this is the modern periodic table or long form of periodic table. So then what is a periodic table then? Periodic table is arrangement of all the elements according to their increasing atomic number and recurring chemical properties. And they are arranged in a tabular arrangement of row, which is called a period, and column is called group. The elements are arranged from left to right and top to bottom in the increasing order of their atomic numbers. So if the elements in the same group have same configuration of valence electrons and therefore have similar properties, and elements in the same period will have increasing order of valence electrons. Therefore, as the energy level of atom increases, the number of energy sublevels per energy level also increases. In the periodic table, 94 elements occur naturally, while the remaining 95 to 118 have been chemically synthesized in the laboratory. So then what are these characteristics of periods? The first period is called shortest period, which is containing only 2 elements. The second and the third period are called short periods containing 8 elements each. The fourth and the fifth period are called long periods. It contains 18 elements each. Sixth period is the longest period with 32 elements. And seventh period is the incomplete period. Lanthanides and actinide series consist of only 14 elements and they are placed below the main periodic table. And these are related to 6th and the 7th periods of 3rd B group respectively. So elements of the 3rd period from sodium to chlorine are called typical elements as they are most commonly used elements. The valency increases from 1st to 7 with respect to oxygen in the period. So we can see here, according to the increasing order of the valencies, the elements how they are arranged in the 3rd group. In the same way, with respect to oxygens, there is an increase in the valency. Na2O valency is 1, MgO2, Al2O3 3, SiO2 4, P2O5 5, SO3 6, Cl2O7 7. So then what are the characteristics of groups? See, Moseley periodic table consists of 18 groups. And these are represented by Roman numbers 1, 2, 3, 4, 5, 6, 7 and 8 and 0. And the groups 1 to 7 are divided into 2 subgroups, that is A and B. And group 8 consists of 3 sets, each one containing 3 elements. And the inert gases are also present in 0 group, that is the 18th group. The valency of the element is equal to the group number. So if the group number is 1, the valency is 1. If the group number is 3, the valency is also 3. And there is no resemblance in the elements of subgroups A and B of same group except the valency. So A and B subgroup, there is a huge difference, but They may be a resemblance of only valency. So these typical elements are called the normal elements. For example, 1A, 2A, 3A, 4A, 5A, 6A, 7A group elements, they are called normal elements or main group elements or representative elements. And the elements which do not resemble with the typical elements are called transition elements. For example, 1B, 2B, 3B, 4B, 5B, in the same way up to 8 group elements are called transition elements. So the next is periodicity of elements. So what is periodicity? Something which is repeated after a fixed interval. Periodicity means that if elements are arranged in an order, the properties of the elements would repeat after some time or after some period. So in periodic table, every 8th element similar to the property of the first, this is known as periodicity. Therefore, the cause of the periodicity in properties is the repetition of similar outer electronic configuration at certain regular intervals. See, all the elements of group 1A, that is alkali metals, have similar outer electronic configuration, that is NS1, which is given below. Lithium, the atomic number is 3, the electronic configuration is 1s2, 2s1. Sodium, the atomic number is 11, the electronic configuration is 1s2, 2s2, 2p6 and 3s1. Same way potassium, rubidium, cesium, strontium, all these have the outer valence electron or the outer electronic configuration as 4s1 or 1, 5s1, 6s1, 7s1. So we can conclude that elements of the same group have the outer valency as same. The naming of the new elements have been earlier traditionally to discover, and the name was suggested by IUPAC. But to overcome these difficulties, two names or symbols, IUPAC associated with the Commission on Nomenclature of Inorganic Chemistry, that is CNIC. In 1997, IUPAC approved the names on certain points of a prefix is given, or a digit, or a root word, or abbreviation. And the names are derived from the atomic numbers basically, using the numerical roots for 0 and numbers from 1 to 9 by adding the suffix IUM. So if the digit is 0 and the root word is nil and the abbreviation is N. For 1 it is UN, un. Abbreviation is U. For 2 it is bi. The abbreviation is B. For 3 it is tri. The abbreviation is T. For 4 it is quad. The abbreviation is Q. For 5 it is pent. The abbreviation is P. For 6 it is hex. The abbreviation is H. For 7 it is sept. The abbreviation is S. For 8 it is oct. Abbreviation is O. 9 it is N. Abbreviation is E. So as you can see here, if the atomic number is 101, 101, the name is un, nil, un with the suffix IUM. The symbol is UNU. The official name for this element is Mendeleev, that is IUPAC symbol is MD. And for 102 it is un, nil, bi. UNB, nobelium, NO. 103 it is un, nil, trium, UNT, or it is IUPAC official name is Laurentium. So then 104 un, nil, quadium, it is UNQ, Rutherfordium, that is RF. Un, nil, pentium, it is UNP, Dubnium. Anilhexium, it is UNH. Seaborgium, SG. 107, it is Anilseptium, UNS, that is borium. 108, Aniloctium, UNO, Hasinum. 109, Anil. In the same way, it continues. So, the number of elements in each period can be determined by the number of electrons in a stable configuration as given below. So, the period is first, which is having stable electronic configuration, that is 1s2 with the number of electrons 2. Second period 2s2 2p6 with the number of electrons 8. Third period 3s2 3p6 with the number of electrons 8. Fourth period 4s2 3d10 4p6 with the number of electrons 18. Fifth period 5s2 4d10 5p6 with the number of electrons 18. And sixth period 6s2 4f14 5d10 6p6 with the number of electrons 32. And seventh period 7s2 4f1 to 14 6d10 7p6, which is incomplete period. And these elements are classified based upon their electronic configuration, and they are divided into 4 groups, that is S, P, D and F. And this division is based on the number of orbital which receives the valence electrons. So S block elements. The elements in which the last electron enters the s orbital or their respective outermost shell are called s block elements, and these are present to the left side of the periodic table with the group number 1a and 2a, and it possesses first and second group, and the electronic configuration of the valence shell is ns1 to 2. What are the characteristics of s block elements? They are the soft metals with low melting and boiling points. They possess the metallic character, and reactivity of metal increases down the group. They are highly electropositive and have low ionization enthalpy, and they have the valency of +1 and +2. +1 in case of alkali metals and +2 in case of alkaline earth metals. And the most of the elements impart color to the flame. So if you burn them, you get color, and they are the strong reducing agent, and they are poor conductors of heat and electricity. So the next one is P block elements. So these are present in the right side of the periodic table, and it constitutes the group 3a to 7a and 0 group. Non-metals grouped from 13 to 18 of the modern periodic table, and most of these elements are metalloids and non-metals, but some of them are metal also. The last electron which enters the p orbital of the valence shell, and the electronic configuration of the valency shell is ns2 1 to 6, that is from 2 to 7 periods. So then what are the characteristics of p block elements? So it consists of both metals and non-metals. The metallic character decreases from left to right along the period, and metallic character increases from top to bottom within a group, and they form covalent compounds. Their ionization energy is higher as compared to s block elements, and their reducing character increases from top to bottom in a group, and the oxidizing character increases from left to right in the period. So thank you guys for being with me, and if you have any doubts, feel free to comment in the comment box or mail us. Thank you from AskPrep.